What is inertia, and why does everything around us seem to resist change? Inertia is one of the most fundamental concepts in physics, and it plays a silent role in nearly every motion we observe, from a parked car to planets orbiting the sun. At its core, inertia is the tendency of an object to resist changes in its state of motion. If something is at rest, it wants to stay at rest. If it's moving, it wants to keep moving in the same direction and at the same speed. This idea was formally described by Sir Isaac Newton in his first law of motion. According to this law, an object will remain at rest or continue moving in a straight line at constant velocity unless acted upon by an external force. That resistance to change is exactly what inertia is. It's not a force by itself, but a property of matter. One of the most important things to understand about inertia is that it depends on mass. The more mass an object has, the greater its inertia. This is why it's easy to push an empty shopping cart, but much harder to push one filled with groceries. The heavier object resists changes in motion more strongly. The same principle explains why stopping a speeding truck requires much more force than stopping a bicycle. In everyday life, inertia is everywhere. When a car suddenly stops, passengers lurch forward because their bodies want to keep moving. When you quickly pull a tablecloth from under dishes, the dishes stay almost in place because their inertia resists the sudden motion. Even seatbelts exist mainly to counter inertia, preventing our bodies from continuing forward during abrupt stops. Inertia also shapes the universe on a massive scale. Planets keep moving through space along predictable paths because there is little to stop them. Without inertia, motion as we know it would not exist, and the universe would behave in a completely different way. So, inertia is the quiet rule that governs motion, stability, and resistance to change. It explains why things don't move unless pushed, and why once they do, stopping them is never as simple as it seems.